The easiest way to start this conversation is talking about DC, direct current. In standard DC circuits, there is a square waveform when current flows. DC voltage is either on or off. Depending on the point of measurement, it could be a positive or negative difference of potential. DC voltage is easily reversible, making it very useful in motor drive systems. As we get into components, most of our discussion will be on AC, alternating current circuitry. We will briefly describe DC in the intro as it serves to help understand how electrons flow. When it comes to troubleshooting, you can use some of the same principles as long as you know where the power comes from. Direct current's simplest form comes from a battery. Batteries come in many voltage ranges. We're going to use a simple 1.5 volt battery as an example. Batteries create electricity through the use of electrolytes and different types of metal. Yes, a chemical reaction. As stated, in a battery we have a chemical reaction. The chemical in the battery causes one side to store more negative charges and the other side to store more positive charges. Ancient Middle Easterners used the juice of lemons and limes with metal electrodes to electroplate jewelry. Remember earlier I said different materials atoms will have atomic structures that are different than others. Batteries use an electrode surrounded by an electrolyte. The electrolyte causes a chemical reaction in the metal electrode, the cathode. This is the negative side. On the opposite side of the battery is an anode, the positive side, with a different type of metal. The combination of the three things cause the electrons from the cathode to want to move as fast as they can to the anode to balance out the lack of electrons on that side. If we took a bare wire and attached it from one end to the other, the electrons would move so fast that the heat created, I will explain this later, but the heat created could make the battery explode. That's why it's also important not to carry a battery in the same pocket that you have pocket change in. It's important to have something between the cathode, the negative side, and the anode to slow down that electron flow, or the amp draw. This is where we would introduce a load. Loads can be resistive or inductive. I will explain that later. For now, we will use a simple light bulb, which is a resistive load. Again, if we connect one end of the battery, the cathode, directly to the anode, we risk causing an explosion, so we need to introduce a load. Resistors or resistive loads maintain a consistent ability to control that flow or that amp draw. If we add a switch, we then have control over when current can flow also. While we are talking about batteries, understand that you can put batteries in series or parallel with each other. If we put two 12-volt batteries in series, we get a total output of 24 volts. If we put them in parallel, we get 12 volts as an output. However, we get a higher available amperage. The same applies to smaller batteries that we often see in flashlights, TV remotes, and all the things in your life that needs more than one battery. Solar panels produce electricity from the heat of the sun. There is no direct conversion. The solar panel cells are made of a silicon mixed material that when heated, the free electrons start to move, which creates a small DC voltage. They do not store charge. In devices called thermocouples, made of two different metals, heating the device causes the electrons to move, which creates a small DC voltage. Again, they do not store a charge. Remember, atoms like to remain balanced. The electrons try to go where they can to achieve that balance. Alternating current is created by magnets or a magnetic field. If I had a spool of wire in a conductive path and waved a magnet past it, we would see an increase in voltage, shown as a waveform. As we pulled the magnet away, we would see a decrease in the waveform. We are inducing a current flow, kind of like a pump increases water pressure. Remember the word inducing, another word for induction. Induction is the magnetic field pushing the electrons away. Atoms with movable electrons are affected by the magnetic field. Remember, in magnets, we have a north pole and a south pole. So as the north pushes electrons in one direction, south pushes the electrons in the opposite direction, creating an alternating waveform. The waveform we see is just a measurement of increased voltage over a period of time. We will discuss frequency in the next segment. The current flowing through the wire also creates a magnetic field around the wire. The important thing to remember here is we created electron flow using a magnetic field, and we used electron flow to create a magnetic field. It's this magnetic field that creates or induces the electricity we use and the potential difference from one point to another. It's the constant movement of electrons and the magnetic field that does the work. Many engineering types will say that there is a conversion from electrical energy to some form of work. There is no conversion, there is only a reaction. Let's go to where AC electricity is made and bring it to where we work with it.